2.4 tools for finding limits. So hopefully this brings a lot of the stuff we've talked about together. And if I miss something, then let me know. Okay, so one method is plug in the X value. Plug in the X value. So here I have a limit as X approaches 1 of X squared minus 3X plus 1 over X squared minus X plus 2. Can I plug in the X value? Does it violate any rules of math? Okay, if I plug in, so I have so we still have this limit as X approaches 1 of 1 squared minus 3 times 1 plus 1 over 1 squared minus 1 plus 2. And what do we get? What do we get in the numerator? Negative 1. What do we get in the denominator? 2. So what's my limit as X approaches 1? Negative 1 over 2. Okay. I think I just made it worse. Okay. All right. So any questions about the first tool? What's the first tool? Just plug in the X value. As long as you're not violating any rules of math, then you're good to go. All right, number 2. Another method is to factor. Logan, how do I factor this? Okay. So I'm trying to think of two numbers, m times n, that equals 4, and also m plus n that equals negative 4. So it's what? It's x minus 2, yeah. That's going to be my x minus 2. All right, Logan, what about the numerator? Do you recognize this as a difference, a difference, a difference, a difference? Is Mr. Hall stuttering? Logan, do you recognize this as a difference? A difference of squares. Isn't it a difference of squares? What's the rule? I don't know. Does this help if I write it like this? X squared plus 0x minus 4. Would that help?
Yeah.
Okay. I'm trying to think of two numbers. When I multiply them together, I get -4, but when I add them, I get 0. Logan, what's that? Okay. Sounds like with attitude too. Isn't it -2 and +2? And so -2 times 2 gives us -4, but -2 plus 2 gives us 0. So there you go. So those are our two values. So what I would prefer, instead of writing it with this 0 in here, I'd actually prefer that you memorize this special factor, because this is really, really important. You're going to see this. I am very confident that you're going to see a difference of squares on your AP test. So I really, really want you, and if it helps, make this one of your flashcards. How many flashcards do we have so far? There's 3. Unless you have, if you need to memorize the, what was it? The Pythagorean identity. The Pythagorean identity should be a flashcard if you don't know that one. So this one, so far our flashcards are the limit as x approaches 0 of sine of x over x, which is 1. We also have the limit as x approaches infinity of sine of x over x, 0. We also have the limit as x approaches infinity of cosine of x over x, 0. It's also 0. Now, those are the only ones that I have suggested that you use. However, if you don't know the Pythagorean identity, you need to have this one memorized, that cosine squared of x plus sine squared of x equals what? It equals 1. If you do not have that memorized, you need to make that a flashcard. And then if you don't know this, the difference of squares, you need to make this a flashcard as well. If I have a difference of squared, right? A squared minus b squared. It is literally a difference, which means minus, of squares. A difference of squares as a factor becomes what? Yeah, let me write it less sloppy. A minus b and a plus b. So if you don't have this memorized, I want you to make that a flashcard. Okay. Logan, are you good? Okay, so then that gives us over here our x minus 2 and x plus 2. Logan, now what? What can I do now? Wait, hold on. Is that okay? We learn everything through repetition. You learned how to tie your shoe through repetition. You learned your name through repetition. You learned English through repetition. This is how we're going to learn calculus, through repetition. It is really helpful to get that extra repetition for these different concepts by making flashcards. Please listen to your calculus teacher. Please make flashcards. As we continue, this doesn't seem like a lot, but as we continue, the amount of flashcards we have is going to mount. I think it's a great idea to put your flashcards behind the toilet, and that could be a great time that you always do flashcards, or at the breakfast table would be a good idea, or in your car. I don't know if that would be a good idea, because I do want you to watch the road, but at the same time, like at a stop sign, you can look at one of the flashcards, put it down, and then you think about it in your head while you're driving, whatever. Trying to think of different ways of you getting that repetition, but please make flashcards. All right, so what do I do? Natalie, are you good? Yeah. All right, so now what do I do? What do I do at this point if I'm using this factor method? Bentley, what do I do at this point?
You cancel the x minus 1 the x minus 2 on top and one of the x minus 2s on bottom.
Okay, and how does that help?
It makes it so we only, it makes it so there's only, it's simplified essentially.
Okay, so how does that help me find the limit? I said that factoring is one of our tools. How does that, where do I go from here to find the limit?
Now you can insert,
Okay, if I insert, what do I get?
yeah, it does not exist.
Yeah, so what do we have in the numerator?
We have an x minus 2.
In the numerator?
So it will, if when you insert x or the 2, it becomes 0.
If I do,
Or not.
what do I get in the numerator in the top?
You get 4.
I get 4.
And then 0 on
Huh?
bottom.
Is that one of our indeterminate forms?
No.
No. So we conclude, you're right, we conclude that this does not exist. I agree with you. If it's an indeterminate form where we have 0 over 0, then we need to figure out we have to use one of our tools to figure it out. And one of our tools is to factor. All right, are you okay so far with what we've talked about? Okay, we've talked about 2. The first one was? Yeah, just plug in the x value. The second one was?
Factor.
To factor. Let's do another one. Okay, number 3. Well, I can think of another one. All right, so I have the next one is find a common denominator. If I have the limit as x approaches 0 of 1 over x plus 5 minus 1 over 5 over x. Doesn't this sort of feel like something we did in chapter 1? This is called a complex fraction. Why is it called a complex fraction? Yeah, we have fractions and fractions. Do you remember from chapter 1 how we dealt with it? First of all, is this an indeterminate form?
Yes.
0, 0.
Yeah, I have 0 over 0. Yeah, if I plug in 0 here and I plug in 0 here, that gives me 1/5 minus 1/5 over 0, which is 0 over 0. This is an indeterminate form, so there's got to be a tool to fix this. So my suggestion is find a common denominator. All right, so where do we go from here? What did we do with this problem in chapter 1?
Solve like the top and the bottom.
Okay, so didn't we simplify it all together? We did something in the numerator first, and then we dealt with the denominator later, right? Okay, so what do we do in the numerator? All right, we're going to multiply by 1 in the form of 5 over 5. Nice, let's do that. 5 over 5 here. And we're going to, we'll multiply by 1 in the form of what over here? X plus 5 over x plus 5. Okay. So that's going to give us, I have the limit as x approaches 0 of 5 over 5 times x plus 5. I could distribute this, but it's easier later to eliminate things if it's already factored. So I'm going to purposely leave it as a factor here, just so that it'll be easier to eliminate things later. And then I'm going to subtract this x plus 5 over x plus 5 times 5. All over x. Does that look right to you? Besides looking sloppy? Now what? I distribute the negative. Do I distribute the 5? No, right? Because we're subtracting. So that's going to give me, I have the limit as x approaches 0 of 5 minus x minus 5. Does that look right to you? Yeah. Okay, why am I leaving this in factored form down here? Why don't I distribute this as well? Because you eliminate things that are factored, right? I can't do, if it's not factored, you can't eliminate things. So I'm just gonna leave it that way for now. And so that's all over X, right? Or X over 1. Okay, now what? When we divide by fractions, here's a tip.
Keep, change, flip.
Nice. So that's going to give me, and I could do something with this over here, right? What can I do in the numerator there? Yeah, so I'm going to write this as, so I have the limit as X approaches 0 of negative X over 5 times X plus 5 times what? If we do keep, change, flip. 1 over X. Yep. Now what? Yeah, cross cancel the X's, giving me what? So I have the limit as X approaches 0 of what? What's left? Yes, Thomas.
Negative 1 over 5x plus 25 or 5 times x plus 1.
Yeah. Okay, now what?
Now you plug in?
Yeah, plug it in. There's no violations of math.
Not yet.
Yeah. So I plug it in and I get what?
Negative 1 over 25.
Negative 1 over 25. Yep, that is my limit. As X approaches 0, my Y approaches this negative 1/25. 3 tools. What was the first tool?
Plug in.
Just plug it in. The second tool.
Factor.
The third tool.
Common denominator.
Find a common denominator. That's what you're going to have to do, especially when you're dealing with complex fractions. You'll have to deal with this when you're dealing with complex fractions. All right, continue.
Yeah.
Okay, number 4. Expand. I have the limit as X approaches 2. I don't like my approaching symbol. Of X minus 1 squared minus 1 over X minus 2. Is this an indeterminate form?
Yes. Wait.
Do I get 0 over 0?
Yeah.
I plug in 2 minus 1 squared minus 1 over 2 minus 2, that gives me 0. 2 minus 1 is 1, 1 squared is 1, 1 minus 1 is 0, so I have a 0 over 0. That is an indeterminate form. So what was my suggestion? Louder? Yeah, expand it. Expand what? Expand what?
You expand in parentheses.
Yeah, let's expand this. So that gives us the limit as X approaches 2 of X squared minus 1 squared minus 1. Does that look right to you?
No.
No, what did I do wrong?
You expanded wrong.
Yeah. You cannot distribute the exponent unless it's multiplication, right? Unless you have A times B squared, you can distribute that exponent. If because of this subtraction here, you cannot distribute the exponent. So I have to rewrite this as X minus 1 times X minus 1 over X minus 2. Now what? Yes, sir.
Multiply.
Yeah, well, yeah, multiplication in the form of the distributive property. That gives us the limit as X approaches 2 of what? X squared
Minus 2x.
minus 1 minus 1x minus 1x, which would give me minus 2x, okay?
Plus 1.
Plus 1.
Minus 1.
And we still have this minus 1 here, so minus 1 here, all right? Over x minus 2,
Yes.
okay? Can you, is that crowded? All right, so this is what it's supposed to say. I think if I erase this dot here, is that better? Or is it still crowded? What do I do from here?
You could back this.
Let's combine like terms first, and then I agree with you, and then let's factor. So I have x squared minus 2x, does that look right? Is that it? Over x minus 2? Right, these cancel out. Okay, and then Bentley says let's factor. What can we factor, Bentley?
Well, we can factor the.
Okay, what can we factor out of the numerator?
So you can turn x squared minus 2x into x times x minus 2
Okay,
over x minus 2.
Okay.
And then you can cancel it from there.
here, cancel these out, leaving me with the limit as x approaches 2 of x. So what does that equal?
2.
It equals 2. All right, we talked about how many different ways? 4? What are the 4? What's the first one? Just plug it in, plug in the x, see what happens. What's number 2?
Factor.
Factor, and then eliminate. Number 3,
Find a common denominator.
find the common denominator, and the fourth one?
Expand.
Expand. Okay. Okay. Do you remember what a conjugate is?
Yes.
What is a conjugate?
It's when you multiply something like that. I know the definition.
Well, what is, if I have 1 minus the square root of 3, what's the conjugate?
1 plus 3.
Where did you learn that? You don't remember? Okay. Been part of the curriculum last year in secondary math 3. Did we talk about it in this class? No, okay. All right, so number 5 is multiply by the conjugate. That's crowded and messy. I don't know, I never had to define it. A conjugate, the idea of a conjugate is especially when I have something like this. This is really the idea. If I had something like this, 1 over the square root of 2. A square root in the denominator is not considered simplified, so I'm going to multiply by 1 in the form of something to get rid of the square root. So I'm going to multiply in this form with the square root of 2 over the square root of 2. That gives me the square root of 2 over 2, right? That's the idea of a conjugate. Here's another example. What if I have something like this? I have 3 over 1 minus the square root of 3. I'm going to multiply. The square root is in the denominator. That is not considered simplified. So I need to multiply by what? By 1 in the form of what?
Square root of 3 over square root of 3.
How about 1? What's the conjugate of this?
Oh, 1 minus the square
Plus, plus, plus.
1 plus.
Yep, over 1 plus the square root of 3. When I distribute this, when I multiply this, that's going to give me, I'm going to distribute here and here. That gives me 3 plus 3 times the square root of 3 over what? When I distribute, gives me 1 plus the square root of 3, distribute here and here. That gives me minus the square root of 3 minus the square root of 3 squared, which is 3. These cancel out, leaving me with 1 minus 3 in the denominator, which would be minus 2, right? What is the point of a conjugate? It's really to get rid of, if something's not allowed in the denominator, it's a way of getting rid of that. So what's the conjugate of the square root? What's the conjugate of the square root of 5 minus 8? What is it? Say it.
5 plus 8.
Yeah, square root of 5 plus 8. So how do we define that? Yeah, just change the middle sign. Natalie, I think a great way of describing a conjugate is just change that middle sign. Is that okay with you if we keep a simple definition like that? Okay. Okay. So let's go back to limits. These are tools for limits. Okay, my problem is the limit as x approaches 0 of the square root of x plus 25 minus 5 over x. Is this an indeterminate form?
Yes.
Yeah, I get 5 minus 5 in the numerator, which is 0. And then I get 0 in the denominator. This is an indeterminate form. So there's got to be a way to fix this. What is my suggestion?
Multiply by the conjugate.
What is the conjugate? Bentley, what's the conjugate?
The square root of x plus 25 minus, or plus 5, sorry.
Yeah, and we're multiplying by 1, so we're not changing the quantity. So I'll just do the same thing again down here, the square root of x plus 25 plus 5. Okay. What an ugly mess. How do we do this? Bryn, how do I do this? Yeah, let's distribute. Let's distribute. When we distribute, what do we get? The square root times the square root. Yeah, and so that gives me what? When I distribute here, what does that give me?
X plus 25
Okay,
minus 25.
x plus 25. Did you do this and this?
Oh, wait.
Don't we have to?
There's more stuff,
Yeah, because
right?
we have to do that FOIL method, right? You have to
Really
multiply.
not working quite right.
It's all good.
Okay, and then so x plus 25 plus 5 x plus 25.
Okay, so wait. We distributed here and then we distributed here, all right?
And then it would be minus 5 times the square root of x plus 25.
Okay,
And then it would be minus 25.
nice.
And that, and when you combine like terms, that actually just leaves you with an x.
Nice. Just leaves with an x. What about the denominator?
So the denominator would be x minus x plus
What happened to the square root?
square root of x times 25. I was writing it, I just wasn't saying.
It's all good.
And then plus 5x.
Good. Is everybody good with how we got this? We literally did FOIL, right? Over here, we did FOIL. We did first, outer, inner, last. And then a bunch of stuff canceled out. Okay.
And yeah.
So what?
You can pull it at, you can technically pull it, well, there, you could technically make it.
All right, let's go back. Wait, let's go back. I like your idea. What if we just leave it this way as factored form because something could be canceled out?
Yeah, so we could take out the x, so we can cancel out the x, leaving us with 1 over square root of x plus 25 plus 5.
All right. All right, is everybody good with how Bryn found this?
Yes.
Any questions? Bryn, now what?
Okay, then we can just substitute with this.
Yeah, just go back to our first, the first tool of just substituting.
That will be 1/10, but if we want to go more slowly, it would be 1 over square root of 0 plus 25
Good work. Nice. The first method is what? What's the first tool?
Plug in.
Plug it in. What's the second tool?
Factor.
Factor. What's the third tool?
Common denominator.
Common denominator. What's the fifth tool?
Expand.
Expand. What's the sixth tool?
Multiply by conjugate.
Multiply by the conjugate. Good.
Rational.
Yep. Rational. That's how you rationalize the denominator, right?
Yeah. it's
Yep.
called rationalizing the video.
Oh, did it? Did it say rationalize?
It said you can.
Okay. Let's do, oh, you're still watching the videos. Nice. Oh yeah, you want me to back out? Let's see if it's too small. Is that too small? Okay. Okay, now this is for trig, for limits of trig. Let's see, this is number 6, right? This is number 6. Yeah, okay. Okay, this is for limits of trig. Use what? Yeah, the limit as x approaches 0 of
Sine of x over x.
sine of x over x equals
1.
1. That's why you need to memorize this flashcard. Because this is going to be, whenever you see trigonometry, you need to think of how you can rewrite it for the cards that we have. So let's look at a problem like the limit as x approaches 0 of sine of 2x over 4x. Is there somehow we can incorporate this into this limit so that we can just simplify to 1? Nathan, any ideas?
Could you just like make like I don't wanna explain it, but just kind of put in x approaching 0, sine of x divided by x equals 1 into that, so then you just have 2 over 4.
Can we cancel these out? The problem with that is that by doing that, the problem with that is that this is in the function, and then this is, well, that's to the function. So we're doing something that's, we're canceling something that's horizontal with something that's vertical. Another way of thinking about it is, isn't this an angle? An angle is a measure of a rotation. This is a length, some type of length. So we can't really subtract a length from an angle. They're different types of measurements. Yes, sir, Thomas.
So one way is to go about this is you can see that it's sine of 2x, right? So we're going to need to get a 2x on the bottom.
Yeah, so if I can get, if this is 2x, if I can get 2x here, then that becomes my card. Yes.
But this is really nice because the denominator has 4x, which can be factored into 2 and 2x.
All right, so you're going to say that we have the limit as x approaches 0 of sine of 2x over 2 times x.
Yes, and
Okay.
then you can take the 2 out as 1/2.
Yep. So what we have a rule that says if I have the limit as x approaches some value of c of a constant times a function, what can we do to the constant?
We can take it out.
Does everybody remember that?
That's multiple.
The constant multiple rule. Cool. Okay, we can take that out. So that's what we have here. we have this, in fact, I'm going to add an extra step, Thomas, if that's okay. We're going to say that this is 1/2 times sine of 2x over 2x. Is that okay? Now we have this constant. So what, Kano, what can we do if we have a constant?
Can you put it in front of the limit?
Yep, we can just move that to the front. So I have 1/2 times the limit as x approaches 0 of sine of 2x over 2x. Kano, how does that help?
Then we can just turn some to x over 2x and then.
Yeah, this is all of this is just one, right? That's my card. That's my card. That's just one. And so that gives me so remember how we figured this out? I think the way we figured this out was by using another method where we have, in fact, we'll do this one. We'll do this one later, where we have, this is X, this is Y, and we're trying to think of values that get closer and closer to 0. Is that how we did that one? And we found that as we get closer and closer to 0, the Y value does what? Yeah, so we found we were comfortable with this being true. So here we've replicated that.
No, I know, but you said for sine 2x over
because I have to rewrite it this way. This is my concern. Somebody wanted to simplify this. And we can't do that. So we're trying to think of some way. Instead, we wrote the 4x as 2 times x. We took this 2 out with the numerator of 1. And then we have this sine of 2x over 2x. We could just say that x, we can say that a, if you want, a equals 2x, so that we can rewrite this as the limit as x approaches 0 of 1/2 times sine of a over a, which is basically this idea here that we have up here on the limit. So all of that becomes I have 1/2 times 1, which is 1/2. Thomas.
So something I realized that, or I think I realized is that whenever we have to do like a sine of ax divided by bx.
Wait. I want to follow along. So if you have sine of ax over bx, okay.
Take the limit when x approaches 0 of that.
Okay, so the limit as x approaches 0.
It always seems to equal a over b.
I don't know if that's always true, but
Yeah.
it does. Let's see, a over b. Yeah, that's what it, is that always
I don't know for everything that I've seen.
what we've seen? Maybe you can.
Yeah, that's why I was confused.
So Natalie, you are seeing the same thing, that should be our answer. I don't know if it's always true. I don't know if that's always true. I do feel a little bit nervous about saying it's true because I haven't seen any rule that allows that.
Yeah.
So I'm not going to condone it, but I don't know whether maybe we could create a rule for that. I don't know. That's something that would be worth more of an experiment, more study. All right, are we good with this one? All right, let's look at number 7. Number 7. For absolute values. For absolute values. Remember what?
Piece values.
Remember plus or minus.
Yeah, that.
Remember plus or minus. Why? Well, if I have something like this, the absolute value of x equals 3. What does x equal? plus or minus 3. Is it true that I can plug in -3 there and it equals 3? Yes, it's also true that 3 equals that as well. So we need to remember this is actually a secondary math 2 idea. Whenever I'm trying to solve for something, like if I have the absolute value of x plus 7 equals 5, then when absolute value goes away, plus and minus comes to say. That's something that I just tell my students. I don't, I know that other teachers just say, let's think of this in 2 different ways. Other teachers say, let's think of this in 2 different ways. So I don't care which way you learned it. We can think of this as x plus 7 equals 5 and x plus 7 equals -5. Which way did you learn? The plus and minus or separating them? Exactly, correct. So either way, I say, this is what I say. So if I have the word bike, and this is something I stole from language arts. So when E goes away, ing comes to stay. Have you ever heard of that? I don't know if you've heard of that, but I stole it from language arts. So when absolute value goes away, plus and minus comes to stay. So that's my own rendition of the grammar rule from language arts. When absolute value goes away, plus and minus comes to stay. I've never heard of anybody saying that before other than me. But anyway, it works. Okay, let's go back. Let's do a problem like this. All right, so I have the limit as x approaches -1 of the absolute value of x squared minus 1 over x squared plus x. My first question is this an indeterminate form? Because if it's not, let's just figure it out by plugging it in. Is this indeterminate?
Yeah.
Do we get 0 over 0?
Yes.
Okay, so we have to think of a different way to solve for the limit. So how do we do it? We have 2 possible solutions, right? Because we have absolute value. What are my 2 possible solutions because of the plus and minus? We can say that the limit as x approaches -1 of what? X squared minus 1 over x squared plus x. That's one possibility. What's the other one? The limit as x approaches -1 of what? Yeah, negative x squared minus 1 over x squared plus x. All right, how do I do these? Yeah, factor does. Logan, what does this look like up here? It looks like a special factor. What kind of special factor is that, Logan? Doesn't it look suspiciously like, yeah, so you're thinking that it's a difference of squares?
Yeah.
And so I can rewrite this as what? X minus 1, yeah. Which means I can, and then down here in the denominator, can I do anything in the denominator? Yeah, I factor out an x. What do I have left over? If I just have x, then when I distribute back, I have x squared, which isn't what I have here. Yeah, it's x plus 1. And if I do the same thing with this other function here, that gives me, or the other limit, that gives me negative x plus 1 times x minus 1 over x times x plus 1, right? Is it confusing that I'm doing these at the same time? Good. Okay, now what? What can I do with this? Yeah, let's get rid of the x plus 1s. That leaves me x minus 1 over x. For my other one, we do the same thing. This x plus 1 and x plus 1. So that gives me negative x minus 1 over x. Okay. Now what? Can I eliminate these? And the answer is negative 1?
No,
No. Why not? Why can't I eliminate those? Why?
because of the -1.
Because of the negative 1. These are not factors. The x is not a factor. This x here is not a factor. Okay. So what do I do? Plug it in. If I plug it in, what do I get?
-2 and 2.
Negative
Well, 2.
2. If I plug in that negative 1 here and here, that gives me 2 and
-2. I'll get this out. Or 2 and -2 and -1. There.
all right, so I get, if I plug that in, I get -2 and -1, which is
2.
2, okay. And the other one? -2 over -1, which is
2 and -2.
-2.
No.
Okay.
So then now this.
So Thomas,
What?
no, you're just brilliant. You're very smart.
I'm sorry.
So we have two limits. We have the limit as x approaches to -1 is 2 and -2. Are you guys good with that as their answer?
No,
Why not?
because a limit cannot be approached. A limit cannot be two different things at the same time.
A limit when you approach, if I say I'm approaching specifically from one side or the other side, we can actually come up with a limit. But if I say that I'm trying to figure out a limit when x approaches some value from any side, you can't approach when x incrementally gets closer and closer, or when we incrementally get closer and closer to some value of x, I can't be incrementally getting closer and closer to two values of y. So there's a problem here. So the answer is does not exist because we have two limits. We get two different limits. Yeah, I'm getting two different y values. Yeah. When x gets closer and closer to -1, my y values get closer and closer to two y values. So yeah, that's wrong. All right, there was one other method. I know that we don't have a lot of time. 10 more minutes? 10 more minutes? Okay, there was one other one that I wanted to talk about that I think is really important. This is on the first day, on the very first day, if all else fails, if all else fails, just graph it, right? If all else fails, we can always just use a table. Use a table of values. So that's the example that we did with the limit as x approaches 0 of sine of x over x. We literally did a table of values where here's my x, here's my y, and we're just going to find x values that get closer and closer to 0. Your calculator has to be in what? What mode? Radians. Are you ever going to be in degrees for this class?
No.
No, it'll always be radians, right?
Waiting for that. That's why, right?
The radians are what?
The rad.
Oh, the
That's why we
rad.
use them, right?
Okay, yes.
That's exactly why we use them.
Sine of 1 divided by 1 gives us, let me make sure my mode is correct. Mode is in radians, it is. I'm getting 0.841, something like that. And when I plug in this point, insert, I'm getting 0.9983. And now I'm gonna put in, insert another 0 into here. I'm getting 0.99998. So we are getting closer and closer to a value of 1. We are getting closer and closer to 1. So we conclude that this, actually this equals, or it equals 1. Which tool is the most confusing? Yes,
Probably the multiply by the conjugate.
multiplying by a conjugate. Yeah. And in fact, this is when you, this was a skill called rationalizing the denominator. And when you had problems like, say, 1 over 5 minus the square root of 2, and a square root is not allowed, we multiply by the conjugate. What is the conjugate in this? Actually, let's make this plus. What's the conjugate in this case? Yeah, so we're going to multiply by 1 in the form of 5 minus the square root of 2 over 5 minus the square root of 2. When we distribute this here, here, and here, and here, what happens to the square root in the denominator? It cancels out. Yeah, that's the whole point of a conjugate. So let's do that. Let's distribute this really quick. So I'm going to distribute here and here. That gives me 5 minus the square root of 2. And then if I distribute here using FOIL, what do I get? 25 minus 5 of 2. Okay, now distribute here and here.
Plus 5 square root of 2.
Okay. Is the square root of 2 squared? What's the square root of 2 squared? Square root squared are inverses. They undo each other, leaving me with what? With 2, yeah, leaving me with 2. Okay, now what?
Yeah, of the 5 square, negative 5 square root of 2.
Yeah, these cancel out here, leaving me with 5 minus the square root of 2 over 25 minus 2, which is 5 minus the square root of 2 over 23. Okay, that's called rationalizing the denominator, like a ratio, or not rationalizing, I guess rationalizing, or a rate. I think you're talking about a radical, rationalizing with the getting rid of the radical in the denominator. I think that's what they're referring to. So anyway, really it's a matter of practice. If the conjugate one is the most confusing, you get lots of practice doing that one. So Natalie, you had an important question at the beginning of the period saying, how do we get more repetition? If we learn everything through repetition and you feel that my homework is not enough repetition, I'm going to make a point to go on to College Board and open up some stuff on limits so that you guys can start getting extra practice if you want. Are the quizzes on College Board required? No. It's why will I make those available?
Repetition.
So you can get extra repetition if you need it. What is the homework for tonight?
2.4 quiz.
2.4 quiz. What is all of chapter 2 about?
Limits.
Limits. What are the 4 different types of discontinuity? Jump is one. Oscillating is another. Removable is another. And infinite discontinuity. Those are the 4. What is is it called the intermediate value theorem? I forgot what it's called. Is it intermediate value theorem? What is the intermediate value theorem? What is the intermediate value theorem? That was the last thing we talked about in class last time. Intermediate value theorem. If I have some point here of A, And another point here of B. If these 2 points are connected, then that guarantees what about all of the X's and Y's? They're included. All of the X's, I don't know why that's not obvious. I'm not sure why we have an intermediate value theorem. All of the X's from A to B are all included on the domain. And all of the Y's between A and B are also included on the range. I'm not sure why that's not obvious. If it's a continuous line from A to B, why wouldn't all of the X's and Y's be included from that one point to another? But it's guaranteed. It's guaranteed that they are there. What if I have a problem like this? I have Y. I'm trying to maximize time. I'm sorry. We have like 3 more minutes, I know, but I'm trying to maximize time. I have 3x squared plus 5x minus 7 over x squared plus 2x minus 6. What is the end behavior model? Loud. 3. That's just 3. How did you get 3?
It's just the first two.
The only thing that matters when we're talking about X becoming really large, these don't matter. These other numbers are going to be so much larger when X is large that the other stuff doesn't matter. So we just go with the leading terms, and then what do we do?
And then the X squared.
Yeah, just leaving us 3. Our end behavior model is just 3. Is everybody good with end behavior models? What other fun things did we talk about? What is our rule if I have the limit as X approaches C of f of X times G of X? Anybody remember what the rule is? The limit of X as X approaches C of f of X.
Times the limit of X equals to C.
Yep. Oh, that was something else we talked about. No, just talking, these are just the properties of limits. This was one of the properties of limits. So another one was that if we have, this is a good review. All right, so I know that f of X is continuous at X equals 2. I know that G of X is continuous at X equals 2. What do I know then about f of X plus G of X? Thomas? It's also continuous where? At X equals 2. What do I know about f of X times G of X? Where? At X equals 2. What do I know about f of X divided by G of X? Yeah, as so long as this isn't 0, right? What was the other one? What if I have f of X minus G of X? At X equals 2. I'm guaranteed that it is continuous, that when I add or subtract or I multiply or I divide, I'm guaranteed if individually the functions are continuous at some point, it's guaranteed that when I combine them in those ways, that the function, the new function, is also continuous at 2. What about a scalar? What if I take k times f of X? Or k times G of X? Some vertical stretch. It's also going to be, I'm guaranteed that those new functions will also be continuous when X equals 2.